Example 1, graphing a parametric curve. We're going to sketch and identify the curve defined by the parametric equations, x, which is equal to t squared minus 2t, and y, which is equal to t plus 1. So what we're going to do is, I'm going to show you for the first example. Here we have a table here on the left where we have the values of t going from -2 to +4. And we're going to find the values of x by plugging it into the first parametric equation and then the second one. So let's just go ahead and do one when we know that t is equal to -2. So if we let t equal -2, then we can plug in t in for x, so we have -2 squared minus 2 times -2. And so that becomes 4 plus 4, which is equal to 8. So we get 8 here for the value of x. And then to find y, we're going to plug in -2 in for t. So -2 plus 1 is going to give us -1. Okay, now if we do that for the remaining values, if we put in -1 in for t, so then we get -1 squared, which is 1, plus 2, which is going to give us 3. And then we get 0. If we plug in 0 in for t, for x, then we get 0. If we plug in 0 for t for in the y, 0 plus 1 is going to give us 1. If we plug in 1 for our x parameter equation, so we get 1 minus 2, which is -1. And then 1 plus 1 is going to give us 2. And then if we plug in 2, we get 2 squared, which is 4, minus 2 times 2, which is 4, which is going to give us 0. And then plugging in for y, 2 plus 1 is going to give us 3. And then we plug in 3. 3 squared is 9, minus 2 times 3 is 6, which is going to give us 3. 3 plus 1 is going to give us 4. Plugging in 4, we get 4 squared, which is 16, minus 8, which gives us 8. And then 4 plus 1 is going to give us 5. So now that we've done that, we have 8, -1. So therefore, we have an ordered pair of 8, -1, another ordered pair of 3, 0, another one of 0, 1, -1, 2, 0, 3, 3, 4, and then 8, and then 5. So what we're going to do is we're going to go ahead and plot these points. So over here on our graph, we're going to plot 8 and then -1. And then we have 3, 0. And we have 0, 1. And then we have -1 and then 2. Then we have 0, 3. Then we have 3 and then 4. Then we have 8 and then 5. Okay, so now that we've plotted our points, let's go ahead and then connect our graph here. So we start connecting our points. Okay, so there is our curve, or in this case we call it our parametric curve. So at this first point, at 8, -1, that was when the value of t was equal to -2. At 3, 0, the value of t was equal to -1. At 0, 1, t was equal to 0. At -1, 2, t is equal to 1. At 0, 3, t is equal to 2. At 3, 4, t was equal to 3. And at 8, 5, we saw that t was equal to 4. Now the next thing we need to talk about here is that this is considered our first point, so this is our initial point. And this is our ending point. So that tells us how to be able to draw arrows of the direction of a parametric equation. So starting at t is equal to -2, the next value was t was equal to -1. So we have an arrow that's going from t to -2 to -1. And then we're going to go from t is equal to -1 to t is equal to 0. So we have another arrow going in that direction. And then t is equal to 0 goes to t is equal to 1. That's the next direction. And then t is equal to 1 goes to 2. Then we have another arrow. And then t is equal to 2 goes to t is equal to 3. There's the arrow for that. And then the last one there is our arrow. So therefore, what we've done is we've created a parametric curve by using the parametric equations x is equal to t squared minus 2t and y is equal to t plus 1, using the values of t and plugging it into the equations to get these ordered pairs. Okay, so let's describe this parametric curve here. Okay, now we can say here that a particle whose position is given by the parametric equations moves along the curve in the direction of the arrows as t increases. Notice that the consecutive points marked on the curve appear at equal time intervals, but not at equal distances. That is because the particle slows down and then speeds up as t increases. So it appears that the curve traced out by the particle may be a parabola. Now this can be confirmed by eliminating the parameter t. So if we're looking at these equations, x equals t squared minus 2t, so we have x equals t squared minus 2t. And we know that y is equal to t plus 1. In order to eliminate the parameter, what we're going to do is we can look at y equals t plus 1 and solve for t. So we're going to solve for t. So we have t plus 1, which is equal to y. And so therefore t is going to equal y minus 1. And then what we're going to do is we're going to plug t to be y minus 1 into equation number 1. So in part 3, this is going to be now x, which is going to equal t squared, which is going to be y minus 1 squared minus 2 times y minus 1. And again, what we've done is we've taken what we have for t and plugged it in for t here. So now what we're going to do is now we're just going to go ahead and then expand. So we have x, which is equal to y squared minus 2y plus 1. Distribute the -2, we have -2y, and that's plus 2. So therefore, x is going to equal y squared minus 4y plus 3. That is eliminating the parameter. So just to verify our result, let's go ahead and graph this in Desmos to make sure that it confirms what we just said. So we can put in the actual equation here. So x equals, we get y squared minus 4y plus 3. So let's go ahead and take a look at our graph here. So if we take a closer look, again, there's our value 3, 0. It goes through 0, 1. We also have negative 1, 2, and there's 0, 3. So there it confirms that it is a parabola, and what we've done is we've eliminated the parameter of t. Okay, so in the above example, no restriction was placed on the parameter t. So we assume here that t could be any real number, but sometimes we restrict t to lie on an infinite interval. If we restrict the above example to be in between 0 and 4, so in between 0 and 4, then looking at the figure below is part of the parabola in the above example. In this case here, it's starting at 0, 1, and it ends at 8, 5. And the arrow indicates a direction in which the curve is traced as t increases from 0 to 4. And so in general, the curve with parametric equations x equals f of t and y is equal to g of t, where t is in between a and b, has an initial point and a terminal point.